we're going to look at graphing in vertex form. So vertex form is new. Last time we saw standard form, which is y equals ax squared plus bx plus c. So for example, y equals negative x squared plus 6x plus 4, okay? And remember, we saw things like vertex, axis of symmetry, okay? And you should remember the graph is going to have a U shape that can either open upward or open downward, depending on the leading coefficient. You should note that this one is going to open downward because of the leading coefficient of -1. Okay, so vertex form looks like y equals a times x minus h squared plus k. So it's going to give away that the function is in vertex form are the parentheses, okay? In standard form, there are no parentheses. And as its name would imply, the key element of vertex form is going to be identifying where the vertex is located. So what vertex form does is just through identification, we can spot the vertex. If you have a function in this form, the vertex will be at the point h, comma, k, okay? Notice in the parentheses that, that the h is negative, and in the coordinate it's positive, so h is going to be the opposite sign, since it's negative over here and positive over here, okay? K is positive over here, K is also positive over here, so it's going to be the same sign. All right, let's take a look at how this works. So y equals 2 times x minus 6 squared plus 4. Okay, we always want to start by identifying what the vertex is. Okay, since this is in vertex form, we can immediately see that the x-coordinate of the vertex is going to be positive 6. Again, the opposite of what's in the parentheses. There's a negative 6 in the parentheses. And the y-coordinate of the vertex is going to be positive 4. Okay, so let's plot that. 6, 4 is right here. Okay, now, just like before with standard form, we're going to get 2 points, either left or right side. I'm going to do the right side because that's the way I did in the other lesson. And then we'll get the other side, the left side, from symmetry. So, should remember we're going to make a table of values. X, y equals 2 times x minus 6 squared plus 4. So I'm going to use 2 points to the right. Again, we're looking for x's. So I'm going to use 7 and 8. Now we'll substitute into the function. So the y is going to be 2 times 7 minus 6 squared plus 4. So that's 1 squared. 2 times 1, so that comes out to 6. So we have the point 7 comma 6. And for 8, it's going to be 2 times 8 minus 6 squared plus 4. So that's 2 squared. 4, 8, 2, 4, 8, it's going to be 12. So we're actually going to go off the graph a little bit, but that's fine. So we have the point 8 comma 12. So let's plot these points. 7, 6 is over here, and 8, 12, let's say is like here, okay? And then if we use symmetry to finish off our parabola, 1 to the right of the vertex is at 6, so 1 to the left of the vertex is going to be at 6. 2 to the right of the vertex is at 12, so 2 to the left of the vertex is also going to be at 12, like there, okay? and we'll finish by plotting a smooth curve through our points. All right, next one. Okay, so the vertex of this one is +2, comma, +6. Let's make a table. Well, actually, let's plot this first. 2, 6 is right here. Notice this one's going to open downward because of the negative leading coefficient. So x, y equals negative x minus 2 squared plus 6. So we're looking for 2 to the right of 2, so 3 and 4. So y is going to be negative 3 minus 2. I'm just going to write 1 squared plus 6. So 1 squared 1, negative 1 plus 6, that's going to be 5. So that's 3 comma 5 for 4, negative 2 squared plus 6. 2 squared is 4. The negative makes it negative 4 plus 6, positive 2. All right, so 3 comma 5 is here, and 4 comma 2 is right here. We'll finish off our parabola. 1 to the right of the vertex is at 5, so 1 to the left of the vertex is also going to be at 5. 2 to the right of the vertex is at 2, so to the left is also going to be 2.